Hello everyone, today we're going to look at usaco-training prime cryptarithm. Okay, so for this problem we're given some number of digits and then we're supposed to form a cryptarithm multiplication based on those digits. Okay, so a cryptarion is basically when we multiply two numbers, and the first number has to be 3 digits. In this case it could be ABC, where each letter represents a specific digit. Okay, so in this case, we have the first number is ABC, the second number is DE, and then we do partial products, where the first number is equal to ABC times E, and the second is equal to ABC times D times 10. And then we just sum them to find the answer for ABC times DE. Okay, so for our digits, every single character in this cryptarion has to be in the set of numbers that were given. So for this example, A and B could represent, if we're given 2, 3, and 5, 6, we could use the only numbers from 2, 3, 5, and 7. Okay. And then same goes for this number, and this number. Okay. So for this case, we're given 5 numbers, 2, 3, 4, 6, and 8. And there's only one solution, because the only solution that would work is if the A, B, C, D, and E was equal to 5, and then when you do the partial products, all these digits would belong in the set. Okay, so all we need to do is just output the number of solutions, which in this input would be 1. Okay, so let's just draw this problem. So we're given let's just say A, B, C, and this is D, E. So we multiply them. So over here, let's let's just all these dots. Let's just represent them as numbers. So you will also have this dot here, here, here. Okay. So notice that over here, this would be equal to A, B, C times E, and over here, this number would be equal to A, B, C times D. Okay, and over here, let's just call this number F and G. So this would be equal to that. So then this number would be equal to F plus 10G. Make sure you see why. And then since ABC, it's actually individual digits, then you can define this as 100A plus 10B plus C. This would be equal to 10D plus E. Okay. And since all we need to do to find this out is to have 5 digits, A, B, C, D, and E, we can actually just generate all the possible digits that would be possible. Okay. So what I mean is that, okay, for example, let's just say our list, let's just say in the sample we have 2, we have 3, 4, 6, and 8. Okay. And for this case, A can be either the digits from 2 to 8. 2, 3, 4, 6, 8. So then the time complexity for this would be, so we have 5 choices for A. We have, in this case, we have just n. In this case, n is equal to 5, so we have 5. And then here we would have 5 letters, so this would be 5 to the power of 5. Okay, wait. 5 to the power of 5. So then this would fit. And for the largest n, since there's only 10 digits that are possible, so the largest n would be 10, which then 5 to the 10th would be like it would fit in the time for everything. So then all we need to do now is to check for every single digit. So we just form this number and then we form this number. And then okay, so we're sure that this works and this works. So now after we form this number, we can check this if each digit is in the list we're given. So then we check this, and then you also check this, and after we check that, we also um, check this. Okay, and then if all these checks work, then we can just add one to our answer. Okay, so here let's just include. Okay, so we're reading from crypt1.in and writing to crypt1.out. Okay, so we're given n in a list of numbers, so we can have n in our list of numbers, so we can read n, and then you would just define your list, so it would be a list of n, so then you can read your list. I mean, it's fn, not cn. Whoops. Okay. So now we need to generate all the possible combinations. So we can have our A. Okay, so let's just call this A index. Okay, so it can be from 0 to n minus 1. So AI will be equal to 0. Okay, so you do that for B, C, D, and E. Now for D and for E. Okay. So now remember our first number is called F. Or actually we can first define our ABC. So A would be equal to let's actually call this L for our list. So A would be equal to L of A index, B would be equal to L of B index, C would be equal to L of C index, D would be equal to L of D index, and E would be equal to L of E index. Okay, so now we have our F, which is equal to ABC times E. So you can and ABC will be equal, so actually, ABC would be equal to 100 times A plus 10 times B plus C. And then you will multiply this by E. Okay, let's actually make the indentation better. So over here, our G be equal to, again, it would be the same, because this is for partial products, but this would be times D. Okay. And then our next thing would be the sum of this. Let's call this H. This would be equal to F plus 10 times G. Okay. So now we need to check for if all these numbers work. Okay, so we need to first check F. Okay, so we can actually make a function to check if all the digits of that number works. So we can go, let's call this bool, let's call this F. So we're given a number, so let's call this X. Okay, so basically to extract the digits, you can always take the last digit, which is X mod 10. And then after you check that, you can just divide it by 10. So you can do this while you still have your X. Okay. So then, so the digit we're checking is X mod 10. And after this process, you just divide this by 10. Okay. so you now, okay, let's just call this a flag. So the flag will represent if we found it or not. So let's call this flag. So you may not have found it yet. Okay, so now you loop through, whoops, loop through all the, all the numbers. Then, so if your D is equal to L of I, then you flag will be equal to true, flag true. Okay. So then, if you did not find it, then just return false. Else, you just return true at the end, once you checked all the digits. Okay, so now, let's actually call this f, since we have a f variable over there. Okay, so we need to check if f works, so we check. Okay, so if it works, and this number must be in the range from, it must be 3 digits, and can, okay, so it must be 3 digits. So to do this, we can check it by, because okay, for a 3-digit number to be possible, it has to be less than 1,000. So, and f has to be less than 1,000, and it also has to be greater or equal to because the least 3-digit number is 1,000. Okay, so now you check for g. So also if f of g, and then g also has to be a 3-digit number. So g has to be less than 1,000, and g has to be greater or equal to 1,000. 100. Okay, now here. Okay, so now we need to check for h. So we also check if the digits are valid. Okay, now we have to check if it's a 4-digit number. Wait, actually, I got it wrong. So over here, we have to check if it's this is supposed to be a 4-digit number. So over here, we just add a 0. Add a 0 here as well. Here we add a 0, 0. Okay, so now h has to be a 5-digit number. So we check if h is less than 1, 1, 1, 1, 1, 1. And this is actually h has to be greater or equal to the least 5-digit number, which is 1 with 4 zeros. Okay, so over here you can just increment your answer, and over in the beginning we just define our answer to 0. Okay, so now over here we just print our answer. Okay, so now I'm just going to take the input to check. Okay, let's run this. Okay, so it looks like there's 2. So actually here we can just print A, B, C, D, E. Okay, so we can print, so C out A. It's supposed to be A, B, C times D, E. And we can result this in H. And since we're just debugging, we can just use standard output. Okay, it's saying that we have these numbers. Okay, so it looks like, okay, so we can actually check this. So 328 times 88 is actually, okay, 1 second. Okay, so it looks like, so it's 100 times A times D. Okay, so for digits, we can also print out, okay, we can also print out F and G. So we can, here, it would be like this. So it'd be also equal to F plus 10 times G, which should be equal as well. Okay, it's running. Okay, so it's saying that 328. So right now our F is equal to basically ABC times 8, which looks like it is right. And then so it looks like our G is, it seems like it is kind of like, okay, so over here we have F equals 2624 and our G equal 26240. Okay. Okay, so basically, and then here we have 436 times 88 would be equal to 3488. Okay, so it looks like that is also right, and here's our digits. Okay. Okay, so let's just look back at our constraints. And here we have, okay, so here's our Cryptarithm framework. Product of here, sum of P1 and P2, okay. Okay, so these are all members of this, and this is also all members of that. Okay, so it looks like actually it should be 3 digits, not 4 digits. So all we need to do here is just, again, remove, let's go back to our code, just remove the 0, because, okay, so now let's just check if this is right. Because when we multiply it, the partial product should both be 3 digits instead of 4 digits. Okay, it's compiling. Okay, so it looks like that is right because that is the same as the sample. So I'm just going to submit it. And this problem is called Crypt1, and the language is C++11. Okay, let's go to the problem. Just going to choose the file. Okay, this is called prime Cryptarium. So here, okay. Okay, so it looks like that is right. Okay, so if you have any questions, feel free to leave them in the comments section below. Bye.